Hey everyone, welcome to another video, and today we'll be determining the domain of radical functions. Now, a radical function will always look something like this. Let's have f of x equal to the square root of x. Now, for this example, everything's pretty straightforward. X just has to be greater than or equal to 0 because we can never have a negative number inside the radical. Like if we have -1, for example, that's not a real number, so it cannot be included in the domain. But if we have like the square root of 4, we get 2, and that number we can easily plot this number. Now, what happens when things get a little more complicated? Like for example, if we have f of x equals to the square root of x squared plus 2x minus 15. Now, what I want you guys to do is set whatever inside the radical equal to 0. And stay with me here for a second, because there's a reason we're not setting it to greater than 0. We're just setting this to 0. Minus 15 equal to 0. The reason we're not setting it to equal greater than 0 is because sometimes when we do that, our intervals turn out to be inaccurate. But when we set it to 0, our intervals are perfect all the time. So now we just have to we just have to figure out what value of x makes the equation 0. So let's start off by factoring. This factors to x plus 5 times x minus 3 equal to 0. X minus 3 equal to 0. So we have x is equal to -5 and x is equal to 3. Now these values are going to be the turning point of our graphs, and you're going to see what that means in a second. So once we have our turning points, we're going to make a number line, and we're going to plot these points. For example, let's put -5 right here, and we can put 3 right here. It doesn't really matter where you put them. This is more just to have a visual image in your mind. Now we're going to test value. So we have 3 intervals: -5 and to the left, in between -5 and 3, and 3 and to the right. So let's start off by testing a value on the left of -5. So if we plug a number less than -5, for example, let's plug in -6. So we're gonna have f of -6. Let me plug this into my calculator just to make things faster. We have -6 squared plus 2 times -6 minus 15. We get 9. 9 is a real value, so we're going to have a check mark. That interval is going to get a check mark right here. Now let's test the middle interval in between -5 and 3. So if we select f of 0, which is in between -5 and 3, we're going to get the root of -15. Now, a root of -15 is not a real value, because remember, we can never have a negative inside the radical, so that interval gets a cross. Now let's plug a number on the right of 4. Sorry, we're picking a number on the right of 3. So let's pick 4, and if I plug in 4 into my calculator, f of 4 is going to equal to 9. So that 9 is a real number, so that interval gets a check mark. By the way, the turning points are always going to be included values, so we can draw closed circles. Now, from 3 to the right, the domain is great, so we're going to draw these little arrows. And from -5 to the left, we have a check mark, so that means we're going to draw an arrow. So far, so good. Now, once we have the turning points, this is where we can begin to write the domain in interval notations. So, our values are coming from the left of the number line, because we always go from left to right. So, we can write -infinity, because as we can see by the interval on the left of -5, as the graph approaches to -infinity, the domain remains a real number. So, -infinity, and then it stops at -5, including 5. So we have a bracket, not a parentheses at 5. Then we have the union symbol, and then the graph picks back up at 3, as you can see, including 3. So we're going to have a bracket and not a parentheses because the value is included. So it starts back off at 3, and then it goes all the way to +infinity. Great. So on the test, this would be our answer for the domain of that graph. Very, very straightforward. Okay, so everybody take some notes. Take some notes if you guys are interested. And now we're going to do another example. This example is also going to be pretty straightforward. Because once you get the hang of this, there's no way like a problem can get more complicated. You're just gonna always use the same process. So okay, give me a second. Let me pick out a good example. Okay, x squared minus 16. Now this is gonna test out your algebra skills. So once again, we set the inside of the radicand to equal to 0. 6 equals to 0. And then we can factor this by the difference of two squares, if you guys remember that. So we're going to get x plus 4 and x minus 4 equal to 0. Great, so the turning points of our graph are going to be x is equal to negative 4 and x is equal to 4. This is once again very straightforward. Let's draw our wonderful number line. Plot these points. I should probably plot them closer to the center. I don't know why I always point them more to the side. 4, great. Now let's test our values. Okay, first of all, let's include these values. Let's make a closed circle. And also, as a little bonus, the reason these values are included is because if we plug in negative 4 and 4, the radicand is going to be equal to 0, which is also a real number, so it is included in the domain. If we plug a number less than negative 4, we're going to get negative 5. So if we plug in negative 5, let's have f of negative 5 is going to be 25 minus 16, which is 9. So we allow this number. Let's plug in 0. If we plug in 0, we're going to get negative 16. So that's not a real number. We get the square root of negative 16, which isn't a real number. So it's not included in the domain. And if we plug in number on the right of 4, we're going to get 5. We're going to get 5. And if we plug in f of 5, we're also going to get 9. And that's once again a real number, so it is included. Now we can finish off this number line. And in interval notation, we're going to have negative infinity, common negative 4, included, union. Then the graph picks back up at 4, and it goes to infinity. Okay, great. Okay, guys, so I really hope you enjoyed this video. As always, I'll leave a bonus example in the comments. Please type in your answer, and I'll respond and tell you if you guys are right. I hope I'll see you in the next video. Have a great day, and ace your next math test. Goodbye.